Okay, we're going to have a look at inverse functions. Now, an inverse is exactly what you would expect in normal life, and it just means the opposite. So if we go right back to primary school, a function, for example, y is equal to 2x plus 1. Then we have the x value, and it goes into this function machine, and we times it by 2. And that then gives us 2 lots of this number. And then we put that inside a second function machine, and that adds 1. And that then gives us our output or our answer or range as 2x plus 1. Now the inverse function does exactly the opposite. So it takes the x value and it goes in this end. So I then add 1 to my function, but instead of adding 1, I'm actually going to do the opposite, and because I'm going to undo, I'm going to do the opposite. So I'm going to subtract 1. So out of my function, I then get x minus 1, and then I can put that into my next function, which is to divide by 2, because it's doing the opposite. And then out of my function, I get x minus 1 divided by 2. And this function here, to times by 2 and add 1, is the inverse of this function here, which is to take off 1 and then divide by 2. So those two functions are inverses of each other. And that's what we're going to do with inverse functions. To make it slightly easier, this method for function machines, it works really nicely, but once their functions get more and more complicated, it becomes harder to see. So instead, we can learn a little trick to do inverse functions. And the first thing we're going to do is to actually swap the x and the y over. So we're going to swap x and y. And then once we've done that, we're going to rearrange the equation to then put back y equals at the front. So we're going to rearrange y equals at the front. And that's essentially doing what we did here. So you're swapping out the x and the y, and then the rearranging, you're going to undo this equation, which is where you're going to first subtract 1 and then divide by 2. So it's doing the same thing. So let's have a go at some questions. So y is equal to 4x minus 3. So first of all, we're going to swap the x and y. So step 1, and we're going to have x is equal to 4y minus 3. And then step 2 is to rearrange it and make it y equals. So first of all, I'm going to add on 3 to both sides of my equation, and that gives me x plus 3 equals 4y. And then I can divide by 4, and that gives me my final answer, or my inverse, which is x plus 3 divided by 4 equals y. Now I can't leave my answer as that, because it doesn't really make sense that y can be equal to 4x minus 3, but in the same problem, y can equal x plus 3 over 4. So in actual fact, that isn't y. At the end, I just need to redo that. Now it doesn't really need to make, start again, 1, 2. Now it doesn't really make sense, big thunder. Now we don't actually leave our answer like that, because it doesn't really make sense that y can be equal to 4x minus 3 at the start of the question, but y can also equal x plus 3 over 4 at the end of the question. So instead, I actually need to erase the y, and I need to write down that it is the inverse function. And the way that we do that is through the notation of the power minus 1. And that's not the same as the normal power minus 1, where it makes it 1 over or a reciprocal. Because it's within the function notation, it actually just means the inverse function. So if initially you'd had f of x equals 4x minus 3, your answer would be that the inverse, f minus 1 of x, is equal to x plus 3 over 4. So the inverse function, everything that we're looking at, the notation for that is the function with the index minus 1. And that's what we need to remember to swap at the end. A lot of people lose marks for that in tests. Let's have a look at another example. So this time, let's have a look at, let's change it slightly. So f of x is equal to 2x plus 3 over 5. So on this question, we're going to first of all, we're going to swap over the x and the y. And we know that this part here is the same as y. So when we swap it over, we get x is equal to 2y plus 3 over 5. And then we need to rearrange it to make y equals at the front of the equation. We don't like denominators, so we can times by 5 both sides. And that's going to give me 5x is equal to 2y plus 3. And then from there, I can then subtract 3 from both sides. And that gives me 5x minus 3 is equal to 2y. And then right at the end, I can divide by 2, which gives me my final answer. So I need to remember to use my function notation, which is 5x minus 3 over 2 is equal to y, or in this case, the inverse function is f minus 1 of x. Let's have a look at another question then. So this time we can do slightly harder. So h of x is equal to 2x squared plus 4. So on this one, we need to again realise that this is just y. So the first step is to swap the x and the y over. So I have x is equal to 2y squared plus 4. And now I'm rearranging, so step 2 is to then rearrange it and make it y equals. So I get x minus 4 equals 2y squared. So I've subtracted the 4 from both sides. Then I can do dividing by 2. So x minus 4 divided by 2 equals y squared. And I need to make it equal to y, not y squared. So I can then square root everything to undo the squared. So x minus 4 divided by 2, all square rooted, gives me y. But then again, I need to remember at the end, it's not y, it's the inverse function. And this time, the function was h of x. So that means that it's going to be h minus 1 of x. So you need to make sure you get the right letter there when you do the inverse function. Now what's quite nice about inverse functions is they have some properties on graphs as well. So f of x is equal to 2x plus 1 and the inverse function is x minus 1 over 2. Now if I plot that on a set of axes, we'll notice something quite interesting. So this is my y and my x axis. Now the first function, the original, we could say is y equals 2x plus 1. So when I plot that, it goes through 1 on the y-axis, and it's got a gradient of 2. So let's, for example, say it looks something like this. So that's my function of y is equal to 2x plus 1. Now, if I imagine that the second one is y equals x minus 1 over 2, and plot that one, that's the same as saying it's a half of x minus 1/2. So this time it goes through minus a half on the y-axis, and it's got a gradient of a half. So when I draw it this time, it's going to look something like that. Now I don't know if you can see on here, but it's actually the inverse function is a reflection in the line of y equals x. So it's a reflection in this line. And if we look at where the original function, the y equals 2x plus 1, crosses the axis, we can see it crosses 1 on the y-axis, and it actually crosses at minus 1/2 on the x-axis. And the new function, y equals 1/2 of x minus a half, crosses here at minus 1/2, and it actually crosses the x-axis at 1. So it does the opposite, and we can see there, it's not overly clear on this, but it will always give you a reflection in the line y equals x. So inverse functions always reflect in the line y equals x, which is that red one that I've drawn on the graph. And we need to be wary that not all functions have an inverse. So for example, if I had a quadratic function, so that's a very rough sketches one, then the inverse of that, when I reflect it in the line y equals x, is going to look like this. Now the issue with that is it's not a function. That's a one-to-many function, which is not a real function at all. It's just a relationship. So in actual fact, if I have a many-to-one function, I can't find the inverse function because the function isn't a function. So I would need to restrict the domain and make it a one-to-one function first, so that I could then reflect it and make it also a one-to-one function.